This lesson deals with supplemental problem 213. You can find this problem in the ECE302 ebook in the Chapter 2 Supplemental Problems on page 27. This supplemental problem is based on an article in Popular Electronics in Volume 15, Number 6, which was entitled Polarity Protection for Mobile Equipment. Applying power to a circuit with the wrong polarity usually results in a total damage of the circuit. Suppose you designed an automotive module that required 12 volts to operate, but the customer needs to make the final connection. Because there's some chance the customer might connect it up backwards, let's design a circuit which will always give our module a plus 12 volts no matter which wire is connected to the plus terminal of the battery. What I need is a circuit that always gives me a positive output no matter whether the input's positive or negative. If you think about our rectifier circuits, that's what they did. We had an AC signal coming in, and we produced an output voltage that was always positive. Now a halfway rectifier throws away part of the cycle, the negative part. We're going to have both the positive and negative inputs as possibilities. So a bridge rectifier might be the best solution to this design problem. Let's construct a bridge rectifier using 1N4001 diodes, where in supplemental problem 2.5 we showed that from the data sheet that the drop across the diode was about 0.8 volts at about 100 milliamps. Let's hook up our automotive module where I put the plus sign here and the minus sign here. This is sort of how we hooked up our capacitor and resistive load. A fully charged battery is around 13.8 volts. If we hook this up, what's going to happen? Well, current's going to flow into our module in this direction, come back out this way, and what I've got is the voltage across here is this 13.8 volts minus 2 diode drops. If the diode drops 0.8, that would be subtracting 1.6 from 13.8, that would give me 12.2 volts. My circuit would work correctly because I've got at least 12 volts across it. Suppose that the customer hooked this up backwards and put the plus terminal here and the minus terminal here. Current's going to flow into our module this way, come back out this way. But again, we're going to have a voltage across here. It's going to be 13.8 volts minus 2 diode drops, or 12.2 volts. And this is supplemental problem 213.